A 95 kilogram human will have a volume of about 0.095 meters cubed. If this human exhales the air out of their lungs and stands on a scale in chlorinated water, density 990 kilograms per meter squared, or cubed, then what will the scale read in newtons? All right, so if I'm thinking about this, I'll start by thinking about a net free body diagram. On the person, I've got a buoyant force going up, and then I've got weight going down. And that'll give me a net force, one force greater than the other, and that'll be what the scale reads. So I need to know the volume of the lungs because it says they exhale all the air out. So I went use the internet to figure out the volume of the person's lungs, average volume, 0.006 meters cubed. All right, so let's put all this together. So first I'm going to calculate the weight, and then I'll calculate the buoyant force. Because they gave me the mass of a person, I can use W equals mg to find the weight, and that's the force going down. So that's going to be 95 times 9.8, which gives me 931 newtons. To find the density is equal to the weight of the fluid that would fill the hole created by the person. So in other words, I'll have the density, the rho Vg, so there's density, there's gravity, and the hole created by the person, 995, and I'll subtract out the area of the lungs. Because when they exhale, what would happen is the diaphragm is going to move up and their stomach's going to get a little bit smaller. And how much smaller? Well, it's that number right there. So it's not too small. And that gives me a buoyant force of 863.478 newtons. So now my net force going down is equal to the force going in the same direction. That's the weight going down minus the buoyancy force. And that just makes logical sense. I got weight going down, buoyancy going up. The scale is going to read the difference in these two. So 931 newtons minus the buoyancy force, and I get 67.6 newtons for the reading on the scale.